Good morning, everyone. Yesterday, we learned the theorem of parallel axis. First, we state the theorem of parallel axis, and then we obtain the relation for parallel axis, that is IO is equal to IC plus capital M and small h square. Similarly, there is another theorem we have to study. It is theorem of perpendicular axis. So first was parallel axis. The name itself suggests there were two parallel axes, one passing through center of mass and second was passing through another point O, and they were separated by small distance h. In this case, there are three perpendicular axes, and we have to obtain, first we have to state the theorem of perpendicular axis, and then we have to prove that. It is also known as principle of perpendicular axis. So see here is again one thing must be remembered here. The parallel axis theorem or principle of parallel axis can be used for any type of body, that is rigid body. It may be planar, it may be non-planar, but particularly this perpendicular axis theorem is applicable only for laminar bodies. What is meant by lamina? Lamina is just like a large leaf, that is, you can say the banana tree, leaf of banana tree. So it is just like a lamina, or we can say this paper as lamina, whose thickness is very small as compared to its other dimensions. So the body or the geometrical shape having very small thickness as compared to its other dimensions is called as lamina. And especially this perpendicular axis principle or theorem of perpendicular axis is applicable only for laminar bodies. So we have to state first the perpendicular axis theorem. See here carefully the figure. Here are three perpendicular axes. This is x-axis, y-axis, z-axis. One thing must be remembered, that these three axes are mutually perpendicular. They are also concurrent. Means they have a common point. Again, one thing must be remembered, O is the common point of all these three axes, and through point O, the z-axis cuts the lamina and passes through the lamina. And these two remaining axes are in the plane of lamina, and they are again intersecting at point O, where the perpendicular axis cuts the lamina. We must remember all these things while we have to state the perpendicular axis theorem. So what is perpendicular axis theorem? See here, I first write it mathematically and we will state it later on. So here IZ is equal to IX plus IY. What is IZ? We know I is moment of inertia about Z axis, IX moment of inertia about X axis, and IY it is moment of inertia about Y axis. So this body, this plane lamina, has three mutually perpendicular axes. They are again concurrent, means they have same common point, that is O. Again one thing, that Z axis, which is perpendicular to the plane, cuts the plane of lamina at point O, where X and Y are meeting each other. Again X and Y are in the plane of lamina. So considering all these things, we can state the theorem of perpendicular axis as the moment of inertia of plane lamina about any axis, about a perpendicular axis, is equal to sum of its moment of inertia about two mutually perpendicular axes in the plane of lamina, and these two mutually perpendicular axes intersect at a point where the perpendicular axis cuts the plane of lamina. So statement of theorem of perpendicular axis or principle of perpendicular axis, that moment of inertia of plane lamina about any axis is equal to sum of its moment of inertia about two mutually perpendicular axes in the plane of lamina, and the two perpendicular axes intersect at a point, are intersecting at a point where the perpendicular axis cuts the lamina. So once again, the moment of inertia of this plane lamina about any axis is equal to sum of its moment of inertia about two mutually perpendicular axes in the plane of lamina, and another word is used in your book that all the axes are concurrent, means they have same common point O. So theorem of perpendicular axis states that moment of inertia of this plane lamina about any perpendicular axis is equal to the sum of its moment of inertia about two mutually perpendicular axes in the plane of lamina. The two mutually perpendicular axes must intersect at a point where the perpendicular axis cuts the plane of lamina. So this is statement of perpendicular axis. Now we have to prove the theorem, perpendicular axis theorem. Here consider first explanation of this figure. We have to read this figure. How we can read this figure? Consider a plane of lamina. Let three mutually perpendicular axes, z axis perpendicular to plane of lamina and x and y are two mutually perpendicular axes in the plane of lamina. This plane of lamina can be possibly rotate about the three perpendicular axes. Let a small element of mass dm at point P having position coordinate, this point P has position coordinate x, y, such that we can say draw perpendicular from point P on n, this is distance x. Similarly, draw perpendicular from point P on y axis at point m, this is distance y. Again, the distance of point P, that is of mass dm, from O means z axis is suppose r. So this is total explanation of the figure. Consider a plane of lamina which can be rotated about the three mutually perpendicular axes x, y and z such that axis z is perpendicular to plane of lamina and x and y are mutually perpendicular axes but in the plane of lamina. Here we consider a small element of mass dm. The body consists of such number of small elements of mass dm. At point P, draw perpendicular from point P on y axis and on x axis such that point P has position coordinate x, y, and again let small r be the distance of this point P, that is of mass dm, from z axis. Now the moment of inertia we have to obtain mi of mass dm about x axis, that is Ix equal to, what is distance of this dm from x axis? It is y. So we can write this as y square into dm. This is mi of element mass dm. But we have to obtain total mass of total moment of inertia of the lamina. So for total planar lamina, this moment of inertia is given by for lamina, this moment of inertia about x axis is Ix is equal to integration of this y square into dm. Consider this as equation number 1. So this is moment of inertia of the plane lamina, total lamina about x axis. Similarly, moment of inertia about y axis Iy. See here, what is distance of point P from y axis? It is x. Total moment of inertia, we can write moment of inertia of only dm element, but we have to write total moment of inertia of the lamina. So Iy, total moment of inertia of plane of lamina, is equal to, it is x square into dm. Consider this as equation number 2. Finally, the moment of inertia of this plane lamina about z axis. See here, from z axis, that is, it is passing through point O, distance of point P is r. So about z axis, this moment of inertia is Iz is equal to integration of r square into dm. Consider this as equation number 3. Now see the geometrical part of this figure. In triangle OPM, in triangle OMP, tell me Pythagoras theorem. So small r square is equal to this x square plus y square. X square plus y square, or you can write y square plus x square. So r square equal to this x square plus y square. So instead of r square you can write x square plus y square. Therefore this Iz can be written as integration of this x square plus y square into integration of dm. Now separate these integrations, multiply by dm and separating integrations. So finally we can write Iz equal to integration of this x square into dm plus this integration of y square into dm. But see here carefully, this is x square into dm. From equation 2, integration of x square into dm is y, iy. Similarly, integration of y square into dm is ix. So finally we can write, therefore Iz is equal to, how we can write this x square integration of x square into dm is iy plus ix, where integration of y square into dm is ix. So it is Iz equal to iy plus ix. Also you can adjust the terms and Iz equal to ix plus iy. So this is the statement or proof of the statement, that is perpendicular axis theorem. So once again we can state the principle of perpendicular axis or theorem of perpendicular axis as moment of inertia of plane lamina about any perpendicular axis is equal to the sum of moment of inertia of the plane lamina about two mutually perpendicular axes. The two mutually perpendicular axes are in the plane of lamina and intersecting at a point where the perpendicular axis cuts the lamina. Here O point is there, where perpendicular axis cuts the plane of lamina. So this is the theorem of perpendicular axis. So perpendicular axis theorem कसं स्टेट करणार? परपेंडिकुलर ॲक्सिस थिअरमचं स्टेटमेंट समजण्यासाठी फिगर लक्षात घ्यायला पाहिजे. फिगर एक प्लेन लॅमिना. प्लेन लॅमिना म्हणजे असा सरफेस, अशी बॉडी याच्याचा थिकनेस खूप खूप लहान आहे. केळीचं पान असतं, वहीचं पान आहे तुमच्या, केळीचं पानाचं थिकनेस त्याला लॅमिना म्हणतात असं बायोलॉजिकल लँग्वेजमध्ये. त्याचं थिकनेस खूप लहान आहे त्याच्या बाकीच्या डायमेन्शन्सपेक्षा. हे स्पेशली परपेंडिकुलर ॲक्सिस थिअरम हे प्लेनार बॉडीसाठी अप्लाय करायचं. सो प्लेन लॅमिनासाठी त्याचं एक्सप्लेनेशन करणार याच्यामध्ये एक फिगर गृहीत धरली. प्लेन लॅमिना आहे ज्याच्यामध्ये झेड हा परपेंडिकुलर ॲक्सिस आहे, एक्स आणि वाय हे त्याला म्युच्युअली परपेंडिकुलर आहे पण बॉडीच्या प्लेनमध्ये प्रतलामध्ये आहे. तर झेड ॲक्सिस भोवतीचा मोमेंट ऑफ इनर्शिया हा उरलेल्या दोन ॲक्सिस भोवतीच्या मोमेंट ऑफ इनर्शियाच्या बेरजे इतका येतो. कंडिशन अशी की हे दोन जे ॲक्सिस आहेत ते बॉडीच्या प्रतलात असावे, प्लेनमध्ये असावे आणि ते अशा पॉइंटला इंटरसेक्ट करतात की ज्या पॉइंटला झेड ॲक्सिस त्या बॉडीच्या प्लेनला कट करून खाली जातो. हे स्टेटमेंट आहे. हे झालं पूर्ण एक्सप्लेनेशन फिगरचं. सर्वात प्रथम आपण मोमेंट ऑफ इनर्शिया इलेमेंट मासचा काढला. Ix इक्वल टू अंतराचा वर्ग गुणिले मास. फॉर टोटल लॅमिना इट इज Ix इक्वल टू इंटिग्रेशन. अशा डीएमचं कलेक्शन असतं, प्रत्येकाचं त्या ॲक्सिस भोवतीचं कलेक्शन घेतलं, अंतराचा वर्ग गुणिले डीएम. सो इट इज इंटिग्रेशन. वाय ॲक्सिस भोवती तसंच पाहिलं तर वाय ॲक्सिस पासून याचं अंतर आहे x. एकट्याचं एक्स स्क्वेअर इंटू डीएम कलेक्शन केलं तर इंटिग्रेशन ऑफ एक्स स्क्वेअर इंटू डीएम. सिमिलरली झेड ॲक्सिस पासूनचा अंतर त्याचा आर आहे. तुम्ही डायरेक्ट ओपी स्क्वेअर टाकू शकता, झेडचे आर टाकू शकता. पण फिगरमध्ये पाहिलं तर आपण आर स्क्वेअर बरोबर एक्स स्क्वेअर प्लस वाय स्क्वेअर आहे किंमत टाकून दिलं, त्याला ॲडजस्टमेंट केलं. काही वेळा तुम्ही हे दोघांची बेरीज घेऊ शकता. आणि मग तुम्ही लक्षात येऊ शकता की एक्स स्क्वेअर प्लस आर स्क्वेअर इक्वल टू इथं आय स्क्वेअर प्लस इथं म्हटलं तर असं करा ऑर कुठपासून ह्या दोन्हीपासून सुरू करायचं. कसं लिहू शकता नाव आय एक्स प्लस आय वाय या दोघांची बेरीज करा इज इक्वल टू इंटिग्रेशन पहिलं काय येईल वाय स्क्वेअर इंटू डी प्लस इंटिग्रेशन ऑफ एक्स स्क्वेअर इंटू याच्यात कॉमन पहा काय निघतं त्याला काय लिहू शकता आय एक्स प्लस आय बरोबर इंटिग्रेशन ऑफ इथे काय येईल वाय स्क्वेअर प्लस एक्स स्क्वेअर इंटू डी बट y square plus x square equal to r square equal to OP square which is distance between z axis and point P. So instead of y square plus x square therefore ix plus iy equal to integration of r square into dm and finally ix plus iy equal to iz असं सुद्धा स्टेटमेंट करू शकतात. कोणाला हे नको वाटलं बेरीज करून सेपरेट यांची बेरीज करा अगोदर परत येतं. तर हे झालं थिअरम ऑफ परपेंडिक्युलर ॲक्सिस. मुख्य दोन थिअरम इथं संपले. मेजर पार्ट ऑफ या चॅप्टरचा संपत आला. आता ह्या थिअरमचे ॲप्लिकेशन्स आहेत परपेंडिक्युलर ॲक्सिस पॅरलल ॲक्सिसचे ते आपण नंतरच्या तासामध्ये बघू.